Hello everyone, welcome to the physics studio. In this video we are going to derive condition for maximum range of a projectile. With range of course I mean horizontal range, and note that we will be deriving it for projectiles between 2 points on the same horizontal plane or between two different horizontal planes. For example, if we talk about the ground to ground projectile, we know that the point of projection and the point at which it hits the ground lie on the same horizontal plane. While in the case of a projectile being thrown from a height, the point of projection and the point at which it will be hitting the ground lie on two different horizontal planes, right? So we will be deriving this condition for these kind of cases, and of course it is not constrained that you have to throw the ball or project the ball or the projectile at an angle theta or at any angle above the horizontal. You can also throw it below the horizontal, or you can also throw it horizontally. All right, so in all these cases the condition that we are going to derive will be applicable. But yes, it won't be applicable for the projectiles on the inclined plane, because there will be some more constraints to it. So we will do it later. For the time being, let's derive it for the cases that I have already mentioned. All right, so yeah, let's do it. For the complete motion, let's say I want to find out the total displacement. So this is the initial point and this is the final point. So we want to find out this total displacement vector. Okay, so as we know that in case of projectile, the acceleration is constant, the g vector. Therefore I can use the equation of motion. So I can write s vector is equal to u vector into capital T plus half into g vector capital T square, where capital T is the time of flight, right? Because as I'm taking the total displacement vector, I have to take the total time of flight as well. So this is the equation that I'm getting. And we can also find the velocity with which it will be hitting the ground, right? We can find it out again by using equation of motion. So I can write v vector is equal to u vector plus g vector into capital T. All right, now what I'm doing, I'm multiplying this second equation with capital T, and I'm doing it just for the sake of scaling. I'll let you know that why have I done it. I'll let you know that later, but for now, for the time being, let's say that I have multiplied it with capital T. So by doing that, what I'm getting is v vector into capital T is equal to u vector into capital T plus g vector into capital T square, right? Now, from this equation, it is very much clear that if we take resultant of u vector into capital T and half g vector into capital T square, then I'll be getting the displacement vector. So that is what I have drawn over here. I'm taking this u vector into T, and this vector is half g vector T square, as we know that g vector is vertically downward. So if we take the resultant of u vector into T and half g vector into T square, then I will be getting what? Displacement vector. So by using triangle law, I have drawn displacement vector. Okay. And at the meantime, I can also draw this equation. I can also use this equation, right? Now you will come to know that why did I multiply this equation with capital T, right? You can clearly see there will be some terms which are common in these two equations. As you can see, u vector into T and u vector into T is common. Also g vector T square is here, also g vector T square is here. Only thing is what, here it was half into g vector T square, while here it is g vector into capital T square, right? So that's why I multiplied it with capital T, so that we can have some common terms in both the equations, right? So now what can I do? I can just double it, right? I can just double it. So I already had half g vector T square. If I take one more half g vector T square, then this entire vector, this AB vector will be equal to what? G vector T square, correct? And if we take the resultant of u vector T with g vector T square, u vector T into g vector T square, then I'll be getting what? V vector into T, as per this equation. Okay. So I've already got it. I've drawn it over here. So by doing all these things, I have finally drawn a triangle OAB. And one more thing I would like to bring you notice is that this altitude line is nothing but the horizontal component of S vector, and we know that the horizontal component of total displacement vector is actually range. Okay, so now I want to write area of triangle OAB. So I can do it in two ways, right? I can write this area of this triangle as simply as half into base into altitude. So if I take this AB as base, then the length of base will be GT square. At the meantime, if I take this as base, then this line will be altitude, which is equal to R. Also, we can write the area of this triangle by using the formula that we have studied in the chapter of vectors. That is, area of any triangle can be written as half into magnitude of cross product of its adjacent sides, right? So OA vector is nothing but U vector into T, and OB vector is nothing but V vector into capital T. So we are taking its magnitude half into ut vt sine phi, where phi, I've assumed that the angle between u vector and v vector is phi. So I can write like this, right? So now we have two values of in two ways we have found the area of this triangle. So we will be equating them. On equating, what I get, r equal to uv sine theta by g, sorry, sine phi by g. So we have now found the range, the value of range. So the result for range of the projectile has come out to be u into v into sine phi by g, where phi is the angle between u vector and v vector. Okay. So now if you already know the value of u, if this initial speed is known to you and also this height is known to you, then you can easily find out the value of final velocity, or the velocity with which it will be hitting the ground, right? So it can be found out by using v square equal to u square plus 2gs. So it's not a big deal. But now if u is known, v is known, g is already known. So in order to maximize range, I will have to maximize sine phi, right? And we know that the value of sine phi, the maximum value of sine phi can be equal to 1. So, and that will occur if phi equal to 90 degrees. So by doing this, we have derived the condition for maximum range. And what is that? It says that the velocity at the time of hitting the ground must be perpendicular to the velocity of projection. So v vector should be perpendicular to u vector, then only we will be getting the maximum range. So putting sin phi equal to 1, we will be getting r max equal to uv by g. Okay. So we have derived the condition as well as we have derived the value of R max. But the next question is what should be the angle of projection with respect to horizontal for achieving maximum range, right? What should be this angle of projection if we really want to get the maximum range? So for this, what I am doing, in the same triangle, now I have done some modifications that if we want to have maximum range, then we know that the angle between u vector and v vector should be equal to 90 degrees. So I have drawn like that, and the angle that u vector makes with the horizontal is theta, which is angle of projection, right? So if this angle is theta, this is 90, this is going to be 90 minus theta, and then in this bigger triangle, again this angle is 90, this is 90 minus theta, so this will be theta, right? So in this bigger right angle triangle OAB, if I write tan theta, then it would be equal to perpendicular, and the length of this perpendicular side is ut, while divided by base, the magnitude of base side is vt. So t and t will get cancelled out, and finally we have the relation that tan theta equal to u by v. You can also write in terms of r max. From here you can say that v is equal to g into r max divided by u, right? So on putting that, we will be getting tan theta equal to u square upon g into r max. So this is the angle of projection if you want to maximize the range. Okay. So in this video, we have derived the condition for having maximum range, the value of maximum range, and the angle projection, and the angle of projection for which we will get the maximum range. Okay. So this is a very good analysis, and I hope that this will help you out in your journey of learning and understanding physics. So okay, thank you.